Hello friends, welcome back to PM Data Lab. And huge congratulations for reaching week 4 of our Power BI course. Last week, you mastered the backbone of every professional report. You understood fact and dimension tables. You built relationships that actually make your models smart. You learned primary key versus foreign key. And you compared calculated columns with measures. A turning point for every Power BI learner. And today, we go even deeper. This is the week where everything starts feeling powerful, where the report stops being just data and starts becoming intelligence. Because today, we explore DAX Fundamentals. We dive into advanced DAX and we uncover interview-winning insights, all using our dataset. If you want to practice along, the dataset is already waiting for you in the description. By the end of this video, you won't just build beautiful dashboards. You'll think like an analyst. You'll understand why each function works. And you'll gain the confidence that interviewers instantly notice. Because these skills, DAX, context, logic, they're exactly what separate beginners from the future Power BI pros. So take a deep breath. You're doing amazing. And let's step into the world of DAX together. First, before we touch any formulas, we need to understand what DAX really is. You've probably heard people say DAX is difficult, but honestly, it's not. The only reason DAX feels hard because most people try to learn formulas without learning the logic behind them. And when the logic is missing, every formula feels confusing. So in this session, I'll teach you the logic first. Then I give you simple examples, and then we'll walk together slowly and confidently into advanced queries until you feel like, yes, I can do this. Why DAX matters? If data modeling is the structure of your house, then DAX is the electricity running inside it. It powers your calculations, your trends, your KPIs, your insights. And if you want to grow from beginner to pro, you must understand how DAX thinks. Two simple ideas in DAX. First, filter context. And second, row context. Without understanding these two, DAX feels difficult. But once you understand them, Power BI becomes easy. And honestly, fun. So let's start with the fundamentals using our real data set. Understanding row context with our sales table. Row context means Power BI looks at one row at a time. In our last video, we created calculated columns. Calculated columns use row context automatically. Let's take a real row from our sales table. Sale ID equals sale 00001. Product ID equals PROD 040. Quantity equals 2. Unit price equals 107.07. Now imagine we create a calculated column for sales amount. Go to the sales table, right-click, select New Column, and type this formula. Sales amount equals sales quantity times sales unit price. Press Enter. How Power BI processes this? It multiplies quantity and unit price row by row. For example, row 1, 2 times 107.07 equals 214.14. Row 2, 5 times 287.01 equals 1435.05. Row 3, 7 times 237.33 equals 1661.31, and so on. That is row context. Simple, straightforward, and we already used it last week. Next, filter context. Filter context is the set of filters applied to our data before a calculation is evaluated. It is created by slicers, visual filters, the filter pane, and relationships between tables. Now let's understand this with a measure called average selling price, ASP. Go to the sales table, right-click, select New Measure and type average selling price equals divide sum of sales amount. Sum of sales amount gives total revenue. Sum of quantity gives total units sold. Divide calculates average revenue per unit safely. Now apply a filter. Drag the category column into the filter pane. If a user selects category equals electronics, 1. Power BI filters the product table and keeps only electronic products. 2. That filter flows into the sales table through relationships. 3. The ASP measure now calculates only for those filtered rows. That is filter context in action. DAX Fundamentals. Let's start with DAX Fundamentals, the building blocks of any professional Power BI solution. DAX Fundamentals include 1. Simple aggregate functions. 2. Basic logical functions. 3. Text functions. 4. Basic time intelligence. 5. Direct references. 6. Basic filtering functions. We'll go through each one step by step using your sales, product, customer, and date tables. And instead of jumping straight into formulas, we'll first understand what each category actually means, how it's used, its limitations, and an easy memory trick to remember it. For easy understanding, think of DAX Fundamentals as a logic fun. A for aggregate functions, L for logical functions, O for operators and direct references, G for general text functions, I for intelligent time functions, C for context-aware filtering functions. Memory trick. A logic fun. Very easy to remember. What are aggregate functions? They summarize multiple rows into a single value. Think of them as math summaries of your dataset. Total sales, average price, maximum or minimum values. Functions include sum, adds numbers, average, finds the mean, min and max, smallest and largest, count and count rows, counts rows or values. How they are used? To calculate total revenue, average price per unit, or maximum sales per product. Limitations. Works mostly on numeric columns, doesn't handle complex filters unless wrapped inside calculate, and can't combine multiple columns in a single aggregate. Examples. Let's see the functions one by one, step by step. First, where do we write these formulas? In Power BI, we use measures, not calculated columns, because we are doing aggregations like sum, average, and max. Workflow. Go to Data View or Report View, click Modeling tab, select New Measure. Now let's start with examples. First, the sum function. We want to calculate total quantity sold. Type this formula. Total quantity equals sum sales quantity. Press Enter. Next, the average function. We want to find the average selling price. Do its same step again. Select New Measure. Type this formula. Average selling price equals divide open parenthesis, sum open parenthesis, sales open parenthesis, sales amount close parenthesis, comma, sum open parenthesis, sales open parenthesis quantity, close parenthesis, close parenthesis, close parenthesis. Now, the maximum function. We want the maximum unit price. Do it same step again. Select new measure. Type this formula. Max price equals max sales unit price. Important note. All these are measures because they change dynamically based on filters and slicers. Memory trick. Sum, add everything. Average, divide equally. Max, biggest number. That's it. 2. Logical functions. What are logical functions? They help you make decisions based on conditions. We see one example. Our manager wants to know which sales are above 2000. Step 1. Create calculated column. We must create this in the sales table. Go to sales table, right-click, select new column. Type this formula. High value sale equals if of sales amount greater than 2000, yes, no. Check the answer. Go to table view and see which sales are above 2000. Example. Find premium customer. Go to sales table, right-click, select new column. Type this formula. Premium customer equals if of related of customers equals corporate, premium, standard. Important note. If you get an error, 1. Check column names carefully. 2. Check data model relationship is one-to-many. 3. Remember, related works only in the many side table, not in customers table. Memory trick. If equals yes or no, check and or equals combine rules. Switch equals pick one. 3. Text functions. What are text functions? They help you clean or transform text, which is very useful for labels and formatting. For example, we want to combine product name and category. Let's see workflow. Go to Data View, select the product table, right-click, choose New Column. Type this formula. Product info equals product and minus and product category. Now go to Table View and you will see a new column with product name and category combined. For easy memory trick, concatenate, combine text. Left, take from the start. Right, take from the end. Upper, make uppercase. Lower, make lowercase. 4. Basic time intelligence. Functions like total year to date, same period last year, and date add. Time intelligence helps you analyze data over time, including year-to-date values, growth, and comparisons. Now you have a doubt whether we use measure or calculated column. In Power BI, when working with time intelligence, the correct choice is always a measure. Let's see our first example. Year-to-date sales. Imagine you are a sales analyst. Your manager asks, how much have we sold so far this year? Go to Modeling tab, click New Measure. Then type this formula. Sales year-to-date equals total year-to-date sum of sales amount using the date column. Here. First, Power BI reads the selected dates from slicers. Next, the measure recalculates dynamically. Then, total year-to-date adds sales from the start of the year till today. Next, we see second example. Now your manager asks, are we doing better than last year? Go to Modeling tab, click New Measure, then type this formula. Sales PY equals calculate sum of sales amount with same period last year on the date field. Here, first, Power BI takes the current date context. Next, same period last year shifts it to last year. Then, the measure compares current sales versus previous year sales. Memory trick. YTD means year so far and PY means compare with last year. 5. Direct references and basic filtering functions. Direct references are simple. Imagine you're building a sales report. You want to see sales for electronics only. You can use direct references by dragging product category directly into the visual. Otherwise, you can use filtering functions like filter, all except, and values. Now let's see clear example. Imagine you are a sales analyst. Your manager asks, how much sales came from electronics? Electronic sales equals calculate of sum of sales amount, comma, filter of product of category equals electronics. Here's the workflow. First, filter selects only electronics products. Next, calculate applies that filter to the sales table. Finally, Power BI adds only electronic sales. Memory trick. Filter first, then calculate. Alright friends, before we dive into advanced DAX, I'm giving you one simple memory trick. Just remember this one word. CAVIRP. Yes, CAVIRP. Each letter stands for one important advanced DAX concept. Let's break it down in the simplest way. CAVIRP covers all the big ideas you'll learn next. C is for context transition. A is for calculate. V for variables. I for iterator functions. R for relationship functions. And P for performance optimization. That's it. One word, CAVIRP. And you'll instantly remember every advanced DAX topic coming up next. Now let's understand context transition. What is context transition? Context transition is when Power BI changes the way it thinks. It starts by looking row by row. This is row context. And then it automatically converts that row into a filter, which becomes filter context. This usually happens inside calculate, or when you use a measure inside a calculated column. Don't worry, I'll explain this in the simplest way possible. Let's use a real example from our sales table. First, we create a measure for the average unit price. Go to the sales table, right-click, select New Measure once and type average unit price equals average of sales unit price. Power BI calculates the overall average, and in our dataset, the global average unit price is 255.22. Now comes the interesting part. We create a new calculated column called Adjusted Price. Right-click, select New Column, and write Adjusted Price equals unit price minus average unit price. As Power BI moves row by row, context transition automatically happens. Let's look at a few examples. Row 1. Unit price is 107.07. So, 107.07 minus 255.22 gives us negative 148.15. Row 2. Unit price is 287.01. So, we get 31.79. Row 4. Unit price jumps to 486.28. So, the adjusted value becomes 231.06. So, what exactly happened here? Power BI took each row, converted that row into a filter, and recalculated the measure under that filter. That automatic switch from row context to filter context is what we call context transition. This is one of the most important concepts in advanced DAX. And once you understand this, YAX becomes a lot easier. Alright, friends. Now let's talk about one of the most powerful features in DAX, the calculate function. First, what does calculate actually do? In simple words, calculate changes the filter context. That means it can add filters, remove filters, or completely replace filters before calculating a value. Think of calculate like this. You're telling Power BI, hey, calculate this number, but only under these conditions. Let's make it super easy with an example. Imagine we want to know how much sales did we make only from furniture products. So we create a measure. Furniture sales equals calculate the sum of sales amount, but filter the data where category is furniture. Here's how the DAX looks. Furniture sales equals calculate sum sales, sales amount, product category equals furniture. So what happens here? Power BI first checks the formula. Then calculate steps in and changes the filter context to show only furniture rows. After the filter is applied, Power BI sums only those sales amounts. That's it. So remember this simple idea. Calculate equals calculate something, but with new filters. Once you understand this, DAX becomes a lot more powerful. And honestly, a lot more fun too. Okay, friends. Now, let's talk about something very important in DAX, iterator functions, also called the X functions. These functions do something very special. They calculate row by row and then return one final answer. Examples are SUMX, average X, min X, and max X, and even rank X. So how do these work? Think of it like this. Iterator functions go into a table, look at each row, execute a calculation on that row, and then add all the results together. Let's make it super simple with an example. Suppose we want to calculate total sales. But instead of using sales amount, we want to manually multiply quantity times unit price. We can write a measure like this. Total sales X equals sum X sales, sales quantity times sales unit price. Here's what Power BI does. Row 1, quantity times unit price. Row 2, quantity times unit price. Row 3, quantity times unit price, and so on. Then SUMX adds all those row results to give one final number. That's why these are called iterator functions. Because they iterate, they move row by row. And here's a little memory trick. X means execute per row. Once you understand this, all the X functions become very easy to use and very powerful in your reports. All right, friends. Now we move to another super important topic in DAX: advanced time intelligence. Time intelligence functions help us analyze data over time, like year to date, month to date, quarter to date, or even rolling periods. Let's take a practical example. Suppose we want to calculate year to date sales, but only for electronics products. We can write a measure like this: electronics sales year to date equals calculate total YTD sum sales, sales amount, date, product category equals electronics. Here's what happens. First, total year to D sums the sales amount from the start of the year up to the current date. Then, calculate applies the filter for electronics, so we only include rows where category equals electronics. The result? A single number showing how much revenue electronics products have made so far this year. Time intelligence is extremely useful in dashboards because it allows you to quickly track growth, trends, and comparisons over time. Once you understand this pattern, you can calculate year to date, month to date, Q to D, previous year comparisons, and much more with just a few DAX formulas. All right, friends. Now let's talk about something that makes your DAX formulas cleaner, faster, and easier to read. Variables, or var. Variables let you store a value temporarily, so you can reuse it in your calculation without writing the same formula multiple times. Why is this useful? It improves readability. Your formulas are easier to understand. It improves performance. Power BI doesn't repeat the same calculation over and over. And it avoids mistakes when reusing the same logic. Let's see a practical example. Suppose we want total sales for electronics products above the average price. We can write a measure like this: electronics above average 2024 equals var, average price equals average, sales on main price, return, calculate, sum, sales amount, product category equals electronics, sales on measurement, average price. Here's what happens. First, var stores the average unit price in a temporary variable called average price. Then, return tells Power BI to calculate total sales, but only for electronics products where unit price is greater than average price. See how clean and easy it is? Without var, we would have to write the average calculation twice, and that would make the formula long and confusing. Memory trick. var equals temporary storage. Store a value, use it, done. Once you get comfortable with var, your DAX formulas will become much cleaner and much more professional. All right, friends. Now let's explore relationship functions in DAX. These functions let you fetch data from related tables without writing complicated formulas or merging tables manually. The two main functions are related, related table. Let's start with related. It brings a single column from a related table into your current table. Example: we want to know each customer segment in our sales table. We can write customer segment equals related customers segment. What happens here? Power BI looks at the customer ID in the sales table, finds the matching row in the customers table, and fetches the segment value. Now, related table is the opposite. It brings a table of related rows into your calculation. Example: related orders equals related table orders. This fetches all the orders linked to a specific customer. So you can perform calculations like sum, count, or averages on those orders. In short, related equals bring a single column, related table equals bring multiple rows. All thanks to the relationships you've already set up in your model. Once you understand this, you can easily connect data across tables and make your calculations much more powerful. All right, friends. Finally, let's talk about performance optimization. How to make your DAX formulas faster, cleaner, and more efficient. Even the most powerful DAX formulas can slow down your reports if they are not written efficiently. Here are some key tips. First, use var to store intermediate results. This avoids repeating the same calculation multiple times. Second, avoid unnecessary row-by-row calculations. Use sum or average instead of SUMX if possible. Third, reduce filter conditions inside calculate. Too many filters can slow down the calculation. Fourth, keep your data model tidy. Use the correct relationships, fewer columns, and follow a star schema design. Remember, fast, efficient DAX formulas make your dashboards more responsive and give your end users a much better experience. Once you apply these tips, your reports will not only work correctly, they will also perform super fast, even on large data sets. And that's a wrap for performance optimization. All right, friends. Before we finish Advanced DAX, let's learn an easy memory trick to remember all 6 key concepts. The trick is called CAVIRP equals Power DAX Pro. Let's break it down. C is for context transition. Think row filter. Power BI changes the way it thinks. A is for calculate. It tells Power BI, change the filters, calculate exactly what I want. V is for variables or var. Store it once, reuse it many times, simple and clean. I is for iterator functions like SUMX or AVERAGEX. X equals execute per row, row by row calculations. R is for relationship functions. Bring data from related tables without complicated formulas. P is for performance optimization. Faster formulas, fewer repeated calculations, keep your reports smooth. So whenever you think of Advanced DAX, just remember CAVIRP equals Power DAX Pro. It's easy, fun, and will help you recall everything in your interviews or reports. And that's your simple memory trick for mastering Advanced DAX. Now let's talk about some common interview questions for DAX and tips on how to answer them like a pro. Question 1. What is the difference between row context and filter context? Tip. Start by explaining the concept, then show an example using your dataset, and finally mention why it matters in real dashboards. Question 2. When do you use calculate? Tip. Show a scenario where you want to override filters like calculating sales for a single product category. Question 3. What is the difference between sum and SUMX? Tip. Explain that sum adds a column directly while SUMX performs row-by-row calculations. Use your sales table as an example to show the difference. Question 4. How do you implement time intelligence? Tip. Show YTD or MTD calculations and explain that a proper date table is required. Question 5. Can you explain context transition? Tip. Use a simple measure inside a calculated column. Show how row context becomes filter context and why it is important for advanced DAX. Question 6. How do relationships and DAX functions work together? Tip. Show how related or related table fetch data across tables and why proper relationships make your formulas accurate and efficient. Tips for answering any DAX interview question. 1. Explain, show, why. 2. Always use examples from your dataset. 3. Mention the reason for choosing each function. It shows deep understanding. Remember, friends, interviewers are looking for clarity, logic, and real-world understanding. If you follow these steps, you'll stand out as a confident, well-prepared Power BI professional. And that's a wrap for week 4 of our Power BI course, here at PM Data Lab. You've just mastered DAX Fundamentals, Advanced DAX Techniques, and Key Interview Ready skills. Memory Tricks Recap. Fundamentals, a logic fun. Advanced, CAVIRP. Interview, explain, show, why. Remember, every formula you write, every measure you create, is power turning raw data into insights. Fundamentals equals your foundation. Advanced DAX equals your superpower. Practice daily. Connect DAX to real insights. Congratulations! You're on your way to building dashboards that impress, inspire, and deliver real insights. Stay consistent. Stay curious. And I promise, your Power BI skills will skyrocket. See you in the next week, here at PM Data Lab, where we'll unlock even more advanced techniques to level up your data game. Keep learning, keep building, and keep shining. With PM Data Lab, see you in week 5. Bye!